Alright, so it's time to venture into some quantitative chemistry. As your notes packet says, we live in a quantitative world. Grades, money, times in sports, etc. These quantities answer questions like how much or how many or how long. Chemists spend a lot of time asking and answering questions. For example, how many grams of hydrogen and nitrogen must be combined to make 200 grams of ammonia? And this question emphasizes that chemistry is indeed a quantitative science. We must be able to analyze substances, measure the amount of matter contained in them, convert between these measurements, and calculate information based upon composition and reactions. Alright, so that's where we're ultimately going. But first, how do we typically measure matter? Alright, first off, we can count stuff. Alright, if we can see it, we can count it. So like if we have beakers on the lab bench, or if we have pipettes or whatever, okay, you can count it. Count money, count sheep, the count. But counting is sometimes something we can do. Not quite often in chemistry. Very often we do by weighing. Okay, just like you might in the store. So on a scale, buying jelly beans by the pound, buying apples by whatever form of measurement. And our scales, we typically have them, we're weighing stuff in grams. And then it can also be by volume, all right, whether it be liquid volume or gaseous volume, milliliters, liters, etc. are things that, or units that we can measure stuff in chemistry class. Gallons out there in the American world of measurement. But anyway, so now what we find is frequently we really need to convert from one form of measurement to another. This is like all the math in chemistry. The heart and soul of every math problem, not every, but most math involves conversions between something and something else. And for us, there's a tool that we could use called dimensional analysis, and that is something that we could use to help us with these conversions. We use what's called a conversion factor, and they basically look like fractions, and they have equal measurements on the top and bottom. That does not mean the numbers are equal. And again, so this dimensional analysis is a tool that we're going to be able to use. It's not a requirement that you have to do it this way. But if you're struggling at all and you ask me for help, I'm definitely going to refer to dimensional analysis. So this is conversion factors. Here we have an expression, 1 dozen is equal to 12 items. So we can set up these two conversion factors. 1 dozen over 12 items, 12 items over 1 dozen. Again, the top and the bottom are the same thing. 1 dozen is 12 items. But mathematically, we have a 1 and a 12, so that's going to help us with our conversions. So for example, how many eggs are in 15 dozen? So this is how dimensional analysis can look. So what you do is you take your given piece of information. I have 15 dozen. I place that over 1, so it looks like a conversion factor. And then I take the unit that is up here, so dozen, I take that unit and I have to put it down here, because that's how I have to cancel it out. So this unit, dozen, gets canceled out, and you change it into what you need. So here I want to know how many eggs are in a dozen. Now you can't just put anything up there. It has to be a fact. It has to be true. It has to be something that you know about. Alright, so we do know that there's 12 eggs in a dozen. So then mathematically, I multiply the numbers across on the top. I multiply the numbers across on the bottom. So here it would be 15 times 12 on the top, 1 times 1 on the bottom, and then I would divide. Okay, so this comes out to be 180 eggs. Now I know you're thinking, duh, I could have just 15 times 12. This tool, dimensional analysis, will become much more helpful when we start using chemistry terms and reactions and all that kind of stuff that isn't as familiar to you as eggs and dozen. Alright, so for this problem we used 12 items over 1 dozen, that conversion factor. Here's a question that says, how many dozen are in 864 cookies? Okay, so again, I set up my problem by taking my given measurement, 864 cookies, and then I place that over 1, and then I take the unit, cookies, and put it down in the bottom of the next conversion factor because I have to cancel it out and change it into what I'm trying to find out about. Okay? And again, I can only do that if I know that link, which now I'm using the conversion factor 1 dozen over 12 items. And so again, mathematically, 864 times 1 on the top, 1 times 12 on the bottom, and then I divide. 864 divided by 12, that's 72 dozen. And yes, I know, you could have done it in your head or on the calculator, but again, let this technique work when we get to chemistry and talking about the mole and grams and everything else that we're going to get into. Or maybe even here. How many donuts are in 22 gross? You might not know what a gross is. A gross is a term for 12 dozen. And so I can use dimensional analysis to do these conversions because not every conversion problem is just going to be one step using one conversion factor. So here, I start with what I'm given, 22 gross. I put it over 1. Okay, and that gross goes down to the bottom of the conversion factor. And then I have to change it into something I know. And we see here that 1 gross is equal to 12 dozen. I know that. Alright, but that doesn't finish my question. I want to know how many donuts are in 22 gross. So I have to continue on. I just add another conversion factor. Make sure the units are diagonally opposite so I can cancel out my dozen and finish with what I want to know about, how many donuts that is. I only spelled it differently so it would fit on the conversion factor. But so now again, mathematically, multiply across the top. The bottom is 1 times 1 times 1. So when I multiply those three numbers together, I get 3,168 donuts. Okay, so again, dimensional analysis, very useful tool. Gonna look even more useful when we start doing chemistry math. But I just wanted to introduce the concept to you here with some measurements that you might be a little more familiar with. So from here we're going to go on to the mole and molar mass and some mole conversions. So woohoo! It's going to get exciting. Alright, see you soon.